Thanks everybody for joining the Tech Ethics Meetup. So I think this is our 8th or 9th session. And this time we are extremely honored to have Dan Jeffries joining us today. So Dan is the Chief Technical Evangelist at Pachyderm and also founder of the AI Infrastructure Alliance. He'll be able to talk a little bit more about what each of those are, but just kind of one thing to mention from my side is Pachyderm has been quite an awesome and prevalent I guess constant all the way since the institute actually was created, ultimately being quite critical in answering the question in the context of tech ethics, and more importantly, higher level principles like whether it's algorithmic bias, as well as the underlying components requires like compliance. There's the question of how do you make sure you have the tools and the infrastructure to ensure that those higher level principles can be addressed. And that's one of the really cool things that hopefully today, Dan will be able to give us some intuition, if not also on the questions that will be provided. Just a brief in regards to the context, and in the meantime, I'll be able to pass the screen. The structure of this session will be as all of the previous ones. We'll have Dan kind of like giving an initial set of slides covering some key topics, and then we'll be able to dive into questions. So you'll be able to all ask questions either on the chat or on the Q&A. And by the time Dan finishes, we'll be able to ask him some of those questions and delve deeper into that discussion. So with that said, I'll pass it over to Dan and just kind of like again emphasize our thanks for joining us. It's really great to have you. So over to you.
I appreciate you folks having me on. It's interesting because Selden was one of the first teams that I had run across that had taken ethics seriously and had actually even an algorithmic bias seriously, right? And had put it into an actual code framework. And we're going to talk a bit about that today, where a lot of times what we see when it comes to ethics discussions is basically a philosophical discussion, and there's not actually a practical component behind it. And so we're going to talk a bit about that, today. So that was one of the reasons I was excited to work with you folks. I'll tell you a bit about the AI Infrastructure Alliance, and we'll talk a little bit about Pachyderm at some point too, in the natural context of things. But it's the main thing about the AI Infrastructure Alliance is I saw a need for an industry-wide alliance to really bring a lot of people together who were building infrastructure software in silos. And the only place that an end-to-end solution exists in machine learning is in the mind of marketers. So there's any advanced system is going to need a number of different components kind of bringing it together. And in particularly when you're dealing with questions of bias, and there's a whole number of components that kind of come into it, right? From monitoring and management to explainability, but also really practices. And this is where I see kind of a big challenge. So let's kind of dig into that a bit here. So I call it practical ethics. And I actually, when I started AI Infrastructure Alliance, I actually had a second one, the Practical AI Ethics Alliance, because I'd done a number of different consulting gigs on this subject, right? Where I'd consulted with larger groups trying to build a real practical AI ethics framework. Most of them were not happy with what I had to say. What they were really hoping for, quite frankly, was 10 platitudes to put onto the website. And I actually wanted to give them a complete program. And so the challenge, of course, with ethics is that it doesn't really sell, right? And the Infrastructure Alliance took off much faster, which is natural, right? There's a lot of money behind it. People need the infrastructure software. But I believe the ethics is going to come storming back because it's just going to be absolutely necessary as more and more of these systems start to come into the real world and more business models are built on top of it and regulators get involved in it. So let's talk a little bit about that. One of the things I always talk about is like with the algorithms making more and more decisions in our lives, how do we know that we can trust those decisions, right? And the answer is, I think that we've seen again and again that we generally can't, and we need to understand better. We need to build it into the process. We'll talk a bit about that. There's obviously these kind of big nightmare examples that people have seen, right, of AI going wrong, right? Microsoft A gets exposed to the web. I'm preaching to the choir here because you folks are all intimately familiar with this, but many of these things often really surprise people. Microsoft A getting exposed to the web and quickly, turning into a sort of racist rants, being trained, by humans, playing practical jokes or just mean spirited, right? Humans, whenever you put a machine learning system into the wild, you have a number of different unexpected factors, and it seemed that the folks behind Tay didn't really have an understanding of what they were exposing it to. Or if you look at something like the Uber self-driving car that killed a woman in Arizona, there are a number of different systems involved in that crash. And when you really look at it, when you look at the detailed reports, which I read on, that the auto regulators looked at, it's sadly, you could see exactly where the things started to go wrong. So for instance, and I won't detail all of them, but when you have a safety driver behind the wheel and 95% of the time it's driving perfectly and you don't really have to pay attention, just imagine how hard it is when you're even using cruise control and you've been using it for an hour and you start to zone out a little bit. And now imagine that suddenly your safety driver in the car's been driving for 2 hours and you've done nothing. You're not even turning the wheel. And suddenly it wakes up because it's made a critical mistake with about actually 1.8 seconds to go. So when the Uber driver woke up, it was about 1.8 seconds to go. And in some of the systems, there was an LSTM in there for tracking time series data, so tracking things in space over time. And there was an object convolutional neural net for object recognition. The problem was they weren't really tied together in a very intelligent way, is one of the issues. The convolutional neural net would detect an object, and if it didn't know what it was, if it was listed as unknown, it would discard it. And then when it figured out what the object was, it would pass that over to the LSTM. So the problem was the convolutional neural net was late at night, and it identified the woman as an unknown object, then as a bike, then as an unknown object again, then as a bike, and then as a person. And even worse, every time that it got to it identified the object as a new type of object, it passed it freshly to the LSTM. So the LSTM lost all of its history. And so it really had no sense of tracking the object in space, and it kept resetting over time, right? So these are the kinds of things that you can see. These are really nightmare examples. Other things are adversarial attacks, and we're going to see tons of adversarial attacks. Just people having, natural adversarial attacks, stop signs, graffiti, things like that. I live in Berlin, and there's graffiti everywhere, certainly even fun graffiti. But one of my favorite street signs, or one of my favorite electronic street signs, has like little symbols painted over it. So it's a heart when it's green, and the stop sign looks like, another kind of sign. Those things can really mess up things. And people are going to do it intentionally, right? The anti-facial recognition during protests, these kinds of things that you already saw in protests around the world, right? Or using kind of lasers to stop a drone from being able to see them. These kinds of things are going to continue to crank up as people kind of have these back and forth relationships with artificial intelligence. But look, those are just big problems. And the problem is that the industry and everyone else in the news media tends to just focus on these. But the real problem, in my opinion, is the subtler problems that really get no press whatsoever. So you think about something like the Compass recidivism scores in Florida, which are black box, developed without any sort of openness, that give us a score to a judge about whether someone's going to go is likely to commit another crime. Now, if a judge, for instance, is no real tech background, they may just assume that the computer is correct and is just all knowing, when really nothing can be further from the truth. And you have a number of different challenges with something like this. Everything from everything from the characteristics that are being taken into account or not into account, or even when you think about, and we'll talk about this more a bit later, you may actually have a better algorithm if you were able to take sensitive characteristics into account. So in other words, if I lump together, anyone here who's keen on math is going to know, if I lump together all the white collar crimes, stealing from offices and sort of stealing from a desk and a computer versus robbing a liquor store. You're trying to average all of these together, and they might not be the same thing, right? So these kinds of things are incredibly important, but legally you can't take them into account. So it starts to raise questions of things that made sense in the human perspective in terms of like limiting our use of sensitive characteristics, rightly so. But in terms of the algorithmic perspective, it might actually increase the effectiveness of the algorithm. The problem is, of course, if you do that, then you run into more politics, right? Now who decides which characteristics and when? But so these are very challenging problems, and they're hidden away because you have algorithms that are handing out loans, deciding on job performance, screening resumes, figuring out whether someone has cancer or not, figuring out whether someone should see a doctor. And more of these are kind of creeping in to the mix over and over again. They can also become problems that are economic problems. And people don't tend to think about this. They just tend to think about it in terms of fairness and transparency and things like that, which is fine. But a loan decision algorithm, and this is where I think we can get kind of companies to think about this problem much more seriously. A loan decision algorithm that, for instance, leaves out a number of women or another group that could pay back those loans. In other words, because the data set was biased or in some way, that's actually leaving a ton of money on the table. So there's actually an economic incentive to get many of these things right. So, how do we fix that? So that's really the important question, and one of the things you talk about here. So I'll talk about some practical ways to do it. Explainable AI is going to be there. I say it's cutting edge research. It is. And obviously, Selden and some of the other folks in the Infrastructure Alliance, Fiddler and Arise, some of the other monitoring solutions, they have explainable AI. But there's only so many algorithms in explainability, and they tend to also, quite frankly, to be mostly built around structured data. And because those are ones that we've worked with a lot longer. It's a little bit more challenging, although there are some algorithms that can show a little bit about what algorithm is focused on in terms of looking at an image or interpreting a sound file, things like that. But it is still cutting edge research, and it's going to be for a time. So the answer is not just pure explainability. And in many ways, we're still sort of establishing what explainable is. And it means, to people, it sort of means I want to interrogate the algorithm like I would interrogate a suspect, or and tell me what it is that you were thinking, right? And have the sort of thing answered to us. But really, we've seen with some of the explainability frameworks that sometimes even the existence of explainability frameworks makes some very intelligent data scientists just assume that it's correct, when in fact the explainability, they've done some tests where they introduced nonsense into the explainability, and people interpreting it were still 80% as likely to believe it, even though it made no sense. And these are not people who don't even understand artificial intelligence. So imagine the average person just seeing, well, it explained it, it's all good. It's not. So what do most organizations try to do? Inevitably, they form an AI ethics committee. They get together, they sing songs, and they inevitably put out a report about how AI should be inclusive and fair. The problem is, of course, that these words are nothing but platitudes. They sound really great, but it's ultimately not implementable because they're just abstract concepts and platitudes. Again, these are things that humans understand, and we make the mistake of trying to build an ethics, practical AI ethics system into our solutions with these platitudes and posting these platitudes on the website. What you inevitably find is most of these platitudes are very, quite frankly, wishy-washy. It allows an organization to go in any direction that they want. Well, we believe in this, but in certain instances, we may discard that. That's human politics. That really doesn't have anything to do with an actual ethics program. And so I'm arguing essentially for a middle path. And essentially, I argue that you have to build this into your decision-making process. Now, obviously, if you're a single data scientist or 2 or 3 data scientists in a small organization, that's going to be incredibly challenging. But any advanced team that's larger is going to need multiple teams baked into the system. And I tend to call them an AI red team. I've been calling it this for 3 or 4 years, but people are starting to use that term in a slightly different way than me. So maybe I have to change it at some point, but I'll explain what I think about in terms of a red team. I tend to think of it as 2 different teams: a customer public-facing team and an AI red team, which is more like QA or security for artificial intelligence. Now, the customer public team is trained to respond when customers, which could be internal or external, or the general public, when AI goes wrong. Okay, so this is essentially a set of lay people. Could be public relations team, it could be internal marketing teams, it could be a specially hired team to deal with this. They need to understand how algorithms make decisions versus humans, and they need to have templates for how to talk to the press, to customers, with clear, concise language. So when you look at something, some kind of, again, these sort of big media blow up ones, for instance, Google Photos labeling, and then later Facebook Photos doing the same thing, labeling people of color, as gorillas. Now, imagine this is, you wake up to this as a person of color, and it's incredibly painful to experience this. You're wondering, did somebody do this deliberately? Are they trying to hurt you? Does the company not care about anything? How did they let this happen? And so what happened, of course, is that Google had to kind of just cobble together a response on the fly because they didn't have anything built into this. And somebody messaged them on Twitter, and then they kind of quickly, sort of moved beyond, tried to get a solution to the thing. That's not going to be acceptable in the coming years. You're really going to need to have a team in place that says, look, we understand you're upset. You have a right to be. We're on top of this. Here's the timeline. We're working on this. We're going to fix it. We're going to communicate with you regularly. We're incredibly sorry, and here's how we're addressing it. Right. So you need to have, and then constant kind of explanations of kind of what's gone wrong. This is incredibly important. By the way, this is actionable intelligence. Any company now that's dealing with algorithms that's going to potentially have challenges or going to cause potential problems should be thinking about this right now. If you're in financial services, if you're in healthcare, if you're anything that could potentially turn into something, lending, hiring, discipline, government, et cetera, you should be thinking about this already. The red team, though, is where the rubber meets the road, though, right? This is a group that essentially is in charge of fixing the problem, triaging the problem, right? So this is traditional coders, data engineers, data scientists, MLOps engineers, QA testers, right? They're responsible for coming up with the triage solution and kind of the long-term solution to things. Now, if we go back to the Google Photos example, they got one of the things they did to fix it, quote unquote, is they stopped the system from being able to label anything as a gorilla, et cetera. And now they got a lot of blowback in the press for this, but it is actually an effective triage solution. The problem is they didn't come up with a long-term solution, or they didn't communicate it if they did. So a triage solution is, if you think about it, is the same thing when you come to an emergency room. There's a triage nurse who's trying to decide, do you have a very serious affliction? How quickly can we fix this problem, sorting people into that and saying, okay, this person has a gunshot wound. They need to come in right now. We need to stop the bleeding. And this is, a person who's got the sniffles. They're over here, and then someone in between. So the triage solutions are short-term fixes. That was an effective triage solution, okay? But not an effective long-term solution. A long-term solution, we'll talk about what those things kind of look like. The obvious answer is expanding the size of the data sets, right? And there can be a whole series of things that kind of come into the picture there. So we'll talk a little bit about how that kind of works, expanding the data set, building again, et cetera. We'll talk about that. So, and then when you look at what this team is, and this is where the MLOps kind of infrastructure starts to come more into place. And I was thinking of these things before they kind of became a reality, but they're starting to become more of a reality now. We have some templates from the DevOps world and traditional software coding for how to deal with some of these problems. Now, DevOps being ported over directly to MLOps is not an answer, okay? It's not perfect. In other words, we've had 30, 40, 50 years of development to lead up to that, but we're really on a new branch of the software tree, and there are a number of different aspects to machine learning that don't exist in traditional hand-coded logic. We don't have any kind of training step analogy where you're just sort of waiting for the computer to do stuff and pitting different versions against each other, with hyperparameter tuning, et cetera. We don't have a lot of focus on data cleaning, versioning, ingestion. It's there, but it's secondary. When you think about traditional coding in a hand-coded logic system, the human programmer comes up with all of the logic, codes it out manually, and the data is secondary. You only touch the data, like if I'm doing a login system, you only touch the data once or twice to get the username and password, but it's secondary. Whereas in machine learning, bringing in the data set, curating it, cleaning it, taking various snapshots, keeping track of the lineage, all of these kinds of things becomes central to the types of things that you're doing. So, but the things that do kind of port over from DevOps are things like snapshots, rollback, version control, data management, these sort of CI/CD pipelines, a dev staging production. We are starting to see, and then auditing, right, and logging. So we are starting to see a number of these areas start to develop rapidly. Okay, now I often talk about this concept of a canonical stack in artificial intelligence, right? So a canonical stack being the default stack that people are going to use in artificial intelligence. It doesn't exist yet, and we're still in the early adopter phase. We're developing towards something like that. Think of something like the LAMP stack for web development, right? Where once you have the LAMP stack, it's kind of the default that a lot of people use, 50, 60%. And other people may have more bespoke architectures for specific things, but that enables new kinds of developments to be built on top of it. It enables people to move up the stack, right? So then you end up with something like WordPress on top of that, and then on top of WordPress, drag and drop editors so that a terrible graphic designer like myself can make a website, right? So these kinds of things enable further development, and we're still very early in the development of machine learning infrastructure. Again, a lot of people point to the cloud systems, Vertex, SageMaker, to say, well, these are the big do-all, end-all, but the truth is, they're not. You're always in an advanced team going to have multiple bespoke solutions. Some of the things that you wrote yourself, some of some of the things that you purchased, et cetera. These are going to evolve over time as tools get better and better. Some of them are already there yet. So Pachyderm, for instance, does data versioning and lineage. It fronts an object store as a copy on write style file system where it's taking constant snapshots, and then a Git-like lineage system that's keeping track of what's in those snapshots, the models and the code and the data changing all at the same time. But snapshots and rollback are going to be incredibly important in terms of your practice. So if you introduce bias into your facial recognition database, even from an auditing standpoint, for instance, you may need to be able to go back and pull someone out of a facial recognition database but still retrain the algorithm, right? The laws are coming down very quickly. They may dictate that those things need to happen. But also you need to be able to go backwards in time when these algorithms start to make mistakes. And to do that, you can't have it as a sort of transient lineage in the way that sort of, I love Databricks and Spark, but their concept of lineage is incredibly different than something like Pachyderm's. They tend to think of lineage as just having to do with the experiment tracking. So their default is sort of 7 days that it keeps track of that, and after 30 days, the snapshots are purged. The problem is, if you need to go back and retrain something a month later or 2 months later, you're in big trouble. And that's one of the secondary challenges when we get to monitoring and management of these types of systems. So I asked one of the members of the Y Labs, why wouldn't they just retrofit an existing logging and management system? They said, look, artificial intelligence monitoring is a different animal. You need a different backend, a different engine, because in a traditional logging engine, say a web service, I only care about the current state generally. Is the web server up or down? It's very binary. I may care about the state of that server over time if the server was bouncing and I'm trying to do some forensics, but after a period of time, I don't care once I've solved the problem. Whereas when you're monitoring artificial intelligence, you're monitoring both the training practices, which version of the model's in play, and you're also monitoring its inference over time, which means you need all of its kind of inference decisions recorded over time so you can see anomalies and things that are happening. You may define, and this is where it's starting to get very advanced, with advanced teams like Uber and some of these other very highly advanced, machine learning teams, they have kind of deployment systems that are getting very, very sophisticated. So they might have shadow deployments, which are different than sort of shadow deployments that you have in kind of traditional web coding. In traditional web coding, you might just do a blue-green deployment, roll the things out. You test with 20 containers, and after 20 minutes or a couple of hours, whether it's throwing any serious errors, any 404 errors, or people are getting weird behavior and complaining, and then you just kind of wipe out the old versions and roll out the new one. Whereas what you're seeing with inference engines is sometimes the problems can take a lot longer to show up, sometimes many weeks or even months. And so what they have is kind of a system where there's kind of experimental versions of the model, a shadow system of the main production model, and queries are being fed to both the production model and the shadow model over time, and the monitoring engine is kind of keeping track of its decisions to see if it has any strange outliers or anomalies, right, that they have to be aware of, right? So these are the kinds of challenges that you face in the machine learning systems that exist today. But some of the things, so those things are already starting to get sophisticated. Some of the things that are not yet sophisticated are things like unit and integration tests. And we'll talk a little bit more about that in a few minutes. But there's a few areas that are still very cutting edge and still developing in this space, and some that are starting to pull ahead. Over time, we'll see a Darwinian evolution, a lot of the consolidation of different tools, people starting to standardize on tools that do 5 or 6 different things really well, et cetera. So if I look at the sort of like how this people solve the red team kind of solves these long-term solutions, they're going to have a really a cross-disciplinary team that really has to coordinate across BUs in many ways, right? So they may need, for instance, some legal help. For instance, if they needed to expand a data set, maybe they don't have the data set in-house, maybe they need to buy one. And in such way, they would need to bring in that data set maybe for testing. And as such, they need to have a legal agreement in place to be able to bring it in for testing that would say essentially they're not going to retrain their algorithm for free and use the data set, right, without paying for it. That they're going to test it. If they have good results, they're going to purchase the data set, right, to use it in production, things like that. Or if they need to generate a synthetic data set. This is another example of where kind of the end-to-end solutions don't really exist, again, except in the minds of marketers, where a synthetic data is now getting a whole bunch of investment in the industry because generating some quality synthetic data is a challenge. But it may be the answer to the solution, because you may not be able to get a brand new data set, or it may take time. So for instance, you may have to go out, if you're fixing the photo problem, you may have to go out and take a lot more pictures. And that takes human time to be able to do it. So synthetic data can be faster. Of course, there's challenges with things like synthetic data. We're starting to see new programs like Y data, Verb, things like that, who are working on synthetic data at a much faster rate that's more accurate. If you look at some of the early days of IBM with their health data, they didn't have enough health data in IBM Watson Health, and they generated synthetic data that just didn't prove accurate, and so they ended up having sort of terrible results. I think that we've started to get a better handle on how to generate synthetic data, but it's still an incredible challenge. They may need to have sort of hybrid solutions, right? A rule-based solution, with business rules, right? To combine it, where maybe there's a combined score where you have sort of explainable, simple rules for scoring something in an AI's black box kind of rule engine. You might need a GAN, you might need new models to kind of just to analyze the various sort of attacks that are happening and kind of respond. So there's a lot of creative thinking that has to go on here. We're still, again, in the very early days of this. You're not buying the O'Reilly book on artificial intelligence defense and monitoring. It doesn't exist. You're not buying the how to solve adversarial attacks book or taking the course on that yet. So this is a team that's going to have to invent as much as they're going to be able to purchase. And obviously companies are going to start to fill this gap. Open source projects are going to start to fill this gap over time. But in many ways, you're going to be on the hook to come up with this. And if you don't have a feedback loop built into your system, if you don't have people who are directly responsible for this, stress testing the AIs, building out ways to deal with it, you're going to be in trouble. And that comes back to kind of a testing system, which this is still incredibly rudimentary in the industry. This is something that I believe absolutely has to be ported over from the DevOps model and traditional coding. You're going to need integrated unit tests. They're going to look very different. But you're starting to see these happen with some of the most advanced teams. So, when the self-driving car teams tend to be some of the most advanced, a team like Lyft runs into an edge case where in certain parts of the world, I think the left-hand turn signal or the right-hand turn signal, something like that, was yellow instead of green. It was like 2% of the cars in the world had this. And so the models were just not knowing what to do. And so they needed to, in their virtual environment, they needed to bring in painters to paint yellow onto those and then retrain at that point in time. So you kind of need lineage and you need sort of progressive training to be able to just retrain on the new data instead of retraining on the entire data set, which becomes cost prohibitive and time prohibitive. And then you build, at some point, you're going to really start to need regression tests. So in other words, the model comes out and you throw a number of different scenarios at it, right? Does it recognize yellow? Pass. in a left-hand turn signal? Does it recognize stop signs with an adversarial data set, right? And one that's being updated on a regular basis is still recognizing those stop signs with graffiti on them or directly covered up, right? What does it do in those situations? Does it slam on the brakes? And this isn't just for advanced teams. It's going to also be for much less life and death sort of things, right? I sit on a number of tech councils, and I had a large bank, tell me that they weren't 100% sure what all their models were, doing in terms of how they make decisions. That's not going to be acceptable in a few years. They knew it. Obviously, they were addressing it, and they were looking at trying to understand, how the models are making decisions and whether there's deviation from those, keeping track of all the different models they had in public. But eventually, it's going to boil down to a series of regression tests. They'll probably be human curated data sets. So, for instance, if you have a resume screening system, it might seem very simple, but the fact is, you may be leaving, if you just trust that algorithm completely, you may be leaving a ton of amazing candidates on the surface. So you may need an HR department to come up with a whole series of resumes that are able to go through just a number of different pieces, right? And be able to look at a curated set of resumes that they've scored, right? Maybe from past successful candidates and potential candidates and candidates who washed out in some way, and those kinds of things. And you may have this hand-curated, hand-scored set, which maybe you're testing the algorithm against regularly and giving an audit report. So these kinds of things are just going to be absolutely essential. And I expect to see more and more teams kind of building these in to their practices in the coming years as AI and machine learning develops over the next 5 to 10 years. It's important to understand really that this is kind of a universal problem too. This is not some this problem that only a few folks have and Facebook has when they get negative press, or the big tech has. This is a problem everybody's going to have as these systems become more and more prevalent in the world. I'm already seeing we're at a tipping point now where I'm already starting to see AI-driven business models. Okay, so these are models that simply could not exist with artificial intelligence, and that's something like I saw a company that was using AI photorealistic, and AI-generated catalog models is solving a very interesting problem, right? Because it's very expensive to hire models, or you're not able to hire the full range of models, or maybe you're able to hire models with different body shapes and things like that, but you're not able to put all the clothes on them. Whereas in the AI version of it, you could generate a model with every skin tone and ethnicity and body shape possible for all of your clothes. And that's something that you wouldn't be able to do with kind of a traditional photography system. So we are reaching a point where more and more business models are going to be based totally on artificial intelligence, and they're going to have their own unique logic problems. They tend to be the different kind of logic problems than we see with traditional hand-coded logic, and people are going to need to be able to deal with these. Every organization, we're seeing there's no industry on earth that's not going to be touched by artificial intelligence. Everything from farming to finance and fraud, algorithmic trading, healthcare, et cetera. Every organization is going to face this, and more models are going to be into production, and we're going to need better ways to audit and control these things. It is a universal problem, so it's one to be thinking about right now. Obviously, research into explainable AI is going to continue to accelerate, and we're going to continue to integrate those tools. But we really don't have to wait. Okay, if you have an advanced team, if you have a team that's more than a few data scientists with a laptop, we can design better monitoring managed processes right now based on the best practices that we've already honed over decades of IT development. And then when you have those people in place, they are naturally going to help advance the cause and develop new tools that turn into open source projects or new companies, et cetera, that help solve this problem for everyone. It's going to be essential that we have ways to deal with this in the coming years. So that's it. That's all I got for now. I appreciate everyone's time and for having me on. I'm sure we'll have some questions.
Awesome. Thank you so much, Dan. That was a really good talk. Yeah, like always, with very great content. So a reminder for everyone in the webinar that you can add your questions on the chat and on the Q&A. As soon as you put them, we'll be able to read them out loud. And in the meantime, I already have a very long scroll of questions, and I'm sure Ryan has as well. So I want to start with the first question. What is your perspective and your thoughts of where policy sits relative to all this? I think you've provided a critical perspective in which practitioners and the market, the industry, is introducing the best practices. How do you see regulation and policy interoperate or be relative into this sort of work streams that you're leading? Mm-hmm.
So look, number one, regulation and policy is inevitable. So you can count on it, right? It's already happening in the EU, and it's happening. Different countries are already starting to look at it. I tend to be slightly skeptical of policy as a solution to things, although it can be very effective, right? I mean, for instance, we were able to outlaw, chemical weapons and get a lot of people to agree to it. But I'm also, again, I'll show a little bit of my skepticism. I think we were able to do it because mostly we moved on to more advanced weapons, right? So if I'm more skeptical of something like people being able to ban artificial intelligence weapons, even though there's a number of kind of movements to do something like that, right? I think they're just too tempting for governments and militaries, and they're just they may agree to something and then just do it anyway with black budgets, right? So there's when you think of policies, I tend to think of politics, right? And when you look at things, I also I think that the first legislation is really going to suffer from the problems we talked about earlier, which is they tend to think about it from a philosophical or a human perspective. You just go, cool, we'll just make your algorithms fair and transparent. But what does that really mean? And the problem is nobody can ever define those terms. And when you define the term, you start to realize it's like saying the word God. Okay, you say the word God, and everybody brings their own perspective, and it's a mirror, and they see something different within that word, right? In the same way, when I see the word fair or I see the word transparent, you, me, everyone else on this call is going to hear and see something different. So how do you even come to a thing? So I favor. Look, I know there's going to be regulation, and I hope that data scientists, data engineers, that thinkers within this space are interacting with the policymakers so they make intelligent legislation. I think in general, it's going to be fairly loose. There's going to be some level of auditing, but it's going to be about as effective in many ways as the auditing was able to stop the financial crisis in 2008, right? It's like at some level it gets gamed. So I think it has to be on an individual organization basis. And in the consulting I've done on it is to say, look, there is not a universal ethics. You may think that there is. You're sadly mistaken, I'm sorry to say. We may broadly agree on a few things, like it's bad to kill people, or whatever. But in general, having a universal ethics policy is going to be really challenged. So what you really need to do is ask hard questions as an individual organization. Where do we stand on the particular issues that we are facing? And I believe that's where policy should be, and where you as an organization that's ethical is going to want to have a team of experts, business people. You can't just leave it to HR and people who have no expertise in it. But you do want to include them. It has to be, business people, human resources, engineering teams working together, come up with a solution and say, look, one of the things I did is ask people a series of questions of that were designed to kind of get them to answer things specifically, and then catalog where they fit on an ethics kind of curve when push comes to shove. So in particular, I can think of one where I was consulting on hiring practices, and they were getting an algorithm to do that. And I said, look, everybody knows the correct answers to the questions, right? So if I say, look, is diversity and inclusion as important as getting the top candidates no matter what? And they'll all say, oh, absolutely, no, everybody knows the correct answer. The problem is that's not a policy, right? And in fact, when you start to put these things into the math, it changes the equation. So you have to now actually put your money where your mouth is. You have to say, you know what, diversity is an important characteristic. How do we build that into the algorithm? Or I am just, as an organization, we absolutely are going to try to be blind to that, and we're going to go for whoever has the greatest resumes, right? And the thing is, now you can build a policy in human terms that's wishy-washy. You can put it on paper, you can put a bunch of checkboxes and fake audits that don't really do anything, and then continue to not really do anything about diversity, for instance, in an organization. Algorithms are going to make this more challenging, and I think in many ways a good way. In other words, it's going to make people say, you know what, this is important to me. We do want to have a broader range of candidates or whatever. Let's bake that into the thing. And so that's where I think the policy can be most effective. I think the policies that are going to come from governments and things like that are just going to be too broad and slippery, and they're going to have a lot of weasel room. So I don't think they're going to be overly effective.
Awesome, thank you, Dan. Yeah, and I think one of the points that you mentioned, we actually covered in a meetup in itself. We had a session titled "Whose Ethics?" An analysis of Eastern and Western ethics. So it was very interesting to actually delve into. I am a little bit more optimistic on the regulation side, so it's really interesting to hear your thoughts. Yeah, it'd be really interesting to hear further as we go through some of the deeper questions. I think I can see now we have a couple more. So let's go through. The first question is super interesting. Have you seen any good examples of MLOps in healthcare?
Good examples of like MLOps in the broader or from an ethics perspective? I mean,
I think it just says any good examples of MLOps in healthcare. So I think maybe repeat the question and the representation that you want to cover it, and maybe then give the answer.
Moderna, I mean, I'm working on a futurist book now, and I'm thinking about where things are going in the next 20, 30, 40 years, and with different sections, right? And one of them is biosciences. And so I've done a lot of look at Moderna, which I think is one of the most advanced companies on the planet currently. And they built a digital process from the very beginning, whereas many of the healthcare companies, pharmaceutical companies out there had a lot of paper-based systems. They built machine learning into almost every aspect of their pipeline, their drug discovery and creation pipeline. And they were very smart about it. They basically built a team that said, look, humans do some things really well, computers do some things really well. So the AIs can crunch through big data, find lots of patterns that humans will miss, but humans really need to interpret it and give the insight and the creativity. But the AIs can do great things like, risk in the clinical analysis, right? Trials and repurposing drugs that already exist and finding candidates that exist by looking at various proteins, databases, et cetera, much faster than even a humans could scale. So if you really go and look at a lot of their stuff, they've got some incredible kind of things coming down the pipe, multiple next-gen COVID vaccines, plus COVID/flu vaccines, plus like an AIDS vaccine and a cancer vaccine for different types of cancers, right? All with mRNA. So they've kind of built a completely digital pipeline with machine learning and machine learning operations, quite frankly, built into the entire workflow. It's not perfect, but I think they're ahead of the curve, and a number of companies are going to be trying to catch up over the next 2 to 3 years.
Awesome. All right. Well, yeah, we still have 4 or 5 more questions, but before delving into the others, I don't know if Ryan, you had any burning questions as well that you want to pose to Dan.
I've got some, but let's take the questions from the audience, as it were. Maybe we'll take the question from Mark Robbins. So I'll just read it out. Mark says, "Great talk and insights, Dan. What do you think in the org is most? Who do you think in the org is most interested in responsible and explainable AI today? Your perspective was developer-centric, but I do not see developers driving adoption."
I don't see them driving adoption either, right? You need to have kind of like we look in sales and we tend to look for like a champion in sales, like somebody who just happens to be more passionate about it. That's the people who are going to kind of make it happen. So the organizations that I've done consulting for was like 1 or 2 individuals who decided this was important. And kind of drove it forward and formed a group, but they're really building it from scratch. They tended to be on the business side of the house or have a business/engineering perspective. In other words, they tended to be folks who were multifaceted, right? Not just from a single discipline, right? Interdisciplinary folks. And so I think those are where it's going to have to be driven. I think the best way to convince people, though, if somebody's really interested in this, is I remember an old IBM commercial that was fantastic. I can't remember what year it's from, but it was about like the kind of green movement and caring about the environment before it was cool. It was many moons before that. And there's a fellow giving a talk to a board of like very old, stodgy, men looking very serious in their suits. And the fellow is saying, look, we can save more trees, and we can, clean the air up. And they're all just kind of staring at him like, who gives a crap, right? And, as soon as this is over, we're going to kick him out of the boardroom. And then he's like, and then, we can save $10 million a year. And all of a sudden, all the executives are up, they're dancing around, they're hugging trees, whatever. So my thinking is, you want to bring this back to an economic argument at the business level. And the way to do that is to say one of two things. These things going wrong could either leave money on the table, as I talked about earlier, because you messed up and you excluded people who could have been amazing candidates who would have driven your business further, or you could have left people back who could have paid the loan, or et cetera, right? Those are things. The second thing is, if you make serious mistakes, the algorithm has serious mistakes, and you don't have good command and control policies in there, in finance or whatever, it could lose a ton of money, et cetera. So it could really hit the bottom line hard. Third, it could be a public relations disaster, both internally or externally, right? If you're using a system to promote people or hire and fire people, whatever, and people get passed over, and you don't have any way to explain that the algorithm said it was that, all of a sudden you have a big problem, right? And so from my standpoint, you want to explain the economic damage and also potentially the economic gain from getting these things correctly, right? That's the way I believe that you balance kind of the pure sort of we'll deal with this later approach that you're generally going to see from most people. But I do believe it has to come primarily from the business level, but don't underestimate the power of an engineer who cares about it and has some level of the bigger picture as well. A champion can come from any part of the organization.
Yeah, I absolutely agree as well on that part of not underestimating the practitioners, right? Because ultimately they're the ones that will have an in-depth understanding of the various touch points that are required in, for example, your AI red team samples that you mentioned. So yeah, that's really good insight. Okay, so let's move to another question. I see one in the chat. So it says, how are companies deciding on whether to outsource versus build in-house solution via red team, AI red team?
I think the people I've seen who are building AI red teams for security or kind of adversarial testing tend to be ones that have a very specific need for it so far, if I'm being honest, and they tend to be in-house because it generally, I've seen the ones that tend to be dealing with sensitive data, so financial data, health systems, those types of things where you're starting to deal with something that could seriously affect the bottom line. It's generally not driven by ethics, I will say, in the current state. It's generally driven by, if my trading algorithm has a crazy anomaly, or my ordering algorithm, stock and ordering algorithm for my e-commerce business has an anomaly because black swan event like COVID hits. What happens, right? And how much I could lose a ton of money or destroy the business at the bottom line. And so those are the teams that are starting to worry about that stuff. At first, they are naturally going to swing into ethics, although I don't think that they're the ideal team to kind of promote it, but I do think they're the team to implement it, right? Because they're going to be the ones that are looking essentially to attack and defend the various models that are in production. Not enough teams are doing that, except in things that have to do with sort of finance or life and death. We're going to see it more and more in the coming years, though, especially the one benefit of just sort of regulation is that it may force people's hand and to start thinking about it a bit more. And so we might start to see a broader adoption from that standpoint too.
Awesome. Okay, so let's move to another one. I think there's quite a few still. But I'll pick one that goes kind of like in the back to that, still relevant to the AI red team. So there's a question that says, where do you see the customer facing / public facing red team sitting within the organization, in tech, risk, IT, corporate risk, or within each staff team, etc.?
So I would say the public relations team is primarily just sitting under, under wherever your general PR sits, right? On your whatever business unit your general PR team is going to sit, right? So that I see that as a separate team, right? That's a communications team. So whatever your communications BU is where that sits. In terms of, and then they'll have some crossover with the engineering teams, business teams. I again think that the red team itself is going to be an IT or tech team, right? Mixture of data scientists, engineers, MLOps, and practitioners, et cetera. But I do believe it has to be a cross-disciplinary team, and that it will evolve into that, right? In other words, there's going to need to be people like jettison your ethics committee and put a practical committee together, right? Forget your platitudes. Think of them as a secondary PR step, right? For marketing purposes, but don't think of that as your ethics policy. Think about boiling together an interdisciplinary team and then bake it into whatever BU makes sense. But it has to, in the end, it has to have business, has to have, human resources, has to have those kinds of entities on it. But in the end, it needs to be practical. And so it needs to be implementable in code. It needs to be implementable and at the algorithm level, which means it needs to be an IT team. So I think it needs to sit under the tech organization. There should probably be, someone who's in charge of sort of AI security, AI red team, sitting under the CTO, right? And then risk also is going to have some level of it, right? Especially if you're in banking and areas like that, you're going to need to have the risk auditors and things like that. But they're also going to need to be schooled on how these algorithms do things, right? So I've seen, I recently did consulting, and a group said that, they said that their risk auditors had decided that, if you had internal data and external data, you couldn't combine those two things and take the result of that, the output of that algorithm, and do something with it. So how they came up with that policy is like, who the heck knows? And I could see where it has some value, but also where it may have no value, right, whatsoever, and just be kind of a kludgy answer to something. So I think there needs to be it really needs to be an interdisciplinary thing, which makes it very cross-functional.
Awesome. All right, let's take one more question, and I think we will have to wrap up because we're getting to the top of the hour. The question reads, as human values / biases transfer into testing of systems as well, how do we make sure and how do we make sure testing is unbiased as well as the creation of the systems, i.e. passes our ethics but not everyone's? Yeah.
So this starts to verge back into the philosophical, right? It boils down to, again, each individual organization needing to decide what their ethics are from the beginning on the various issues that they're confronting, right? And the fact is, again, try to imagine that there are going to be mistakes from the human side. They're going to take a position, right, as a company and a group that maybe not everyone in the company agrees with, or certainly not every company is going to agree on the same level of ethics, right? But that's going to be the ethics of that organization. And in essence, that naturally means some level of natural bias. In other words, we tend to think of bias only in the negative, okay? But bias is actually a broad-ranging subject. If I have a bias towards not killing people, that's a bias, right? It's, Machiavelli probably doesn't agree with me, right? Many dictators probably don't agree with me. That's their bias, right? So, but there's a positive bias. And so, in other words, what you want to do as an organization is probably have a lean towards a positive bias, right? In terms of instructing these things. And yes, there's a quantum kind of loop that's happening. The interpreter is interpreting the thing that's happening, right? And introducing their own challenges into it. The best thing to do is kind of scientific method it, right? And this is the way one of the few ways we've been able to kind of root out bias, or root out sort of like one person getting it wrong. The idea, most people think, oh, well, the outliers in science are really important. They're not. It's actually designed to say, like, great, the outliers don't really matter. This 90 percentile of agreement matters in science. So I think in the same way as you kind of have a program where you're sort of looking at the things that you choose and then cascading that down, right? It's implementing that as a concrete policy. That's why you introduce sort of a positive bias. But the way to introduce a surefire negative bias is to do none of that. Just ad hoc it, build an algorithm based on like whatever somebody comes up with that week. Prioritize engagement over everything else. Prioritize whatever over everything else, and never even think about it until it becomes a problem. That's a guaranteed way to have the problem. You have to think about it systemically from the very beginning.
Awesome. All right. Well, so I think yeah, I mean, there's probably going to be still more questions, but it'll be very hard to go through all of them. I think, yeah, there is quite a lot of resources that I know, Dan, you also have online. So if you were to point people to any resource, like where, would they go maybe for the AI Infrastructure Alliance? I will also share the links on the meetup page as well.
Yeah, you can check out the AI Infrastructure Alliance. That's going to be going through a site revamp very soon, and we're going to start to have a lot more research on there. At the end, the ethics is going to be a serious component for in 2022. I've privately shared out some larger research that I've done with it, but I would start at the AI Infrastructure Alliance. I actually would say I wish that there were more resources out there on this, and I feel like it's still a question that is developing, and it too often kind of takes a backseat to, just the practical implementations of things and making money. We all need to make money. I like money. You like money. It's great and necessary. I don't think of it as evil. I think it's wonderful. I'd love to have more of it, and I'm sure you would too. But at the same time, it is important to kind of think about these things. And most of the frameworks that I've seen out there have been quite disappointing, quite frankly. And so I'm actually hoping to sort of externalize some of my frameworks. I could dig up the kind of private writing I've done on some of it, maybe share that out with folks. I'd be interested to see what they had to say about it.
Awesome. Yeah, I think that'd be great. Yeah. So we'll sync and we'll put those all in the meetup page. And I think that is a great note to end on. Again, yeah, thank you so much, Dan, for joining and sharing those insights. And thank you to all the attendees for joining us today. So I guess with that, we'll see you on the next meetup.
Thanks, everyone.
Thank you all.